Good morning, everyone. Thank you for joining us today and joining our webinar as we discuss observability for self-hosted Temporal. So this session is designed for our Temporal open source users and team self-hosting Temporal. And we will offer some practical insights into observability for Temporal Server. We'll have Q&A session with our speaker today at the end of the presentation. So please feel free to add your questions using the Q&A feature below, and we will add it to the queue. Also, we are recording today's session, and we will send you a copy of this so you can revisit and share with your friends and colleagues. And I would love to present our speaker today. This is Tihomir from Temporal. He is Senior Staff Developer Success Engineer here. And over 3 years, he has been helping Temporal community users with their technical questions. So, hi, Tihomir.
Hey, hi. Thanks, Irina, for the introduction.
Yeah, I think we can get started.
All right. So hi, everybody. Thank you all for joining. Thank you for the nice introduction, Irina. So I start usually my slides off with a quote: experience tells you what to do, confidence allows you to do it. These types of talks that I'm usually doing is sharing some of the experiences that I've had over the years, helping users and customers, temporal customers and users with technical questions, issues that we ran into and things like that, and the things I learned, and to kind of help you out and give you the confidence to actually go out there and do it and try it out, and to always know you're not alone. We all at Temporal, we love our community and we really try our best, and I know that since I've been part of it for a long time, to help you out and welcome you and help you have success with Temporal. In addition to these types of talks that I'm doing, we also do community sessions. And here you have some links to two things. There's design discussions, worker tuning sessions. They're 30 minutes. And then we have some observability on both worker and service metric size. There are 45-minute sessions that you can go to Calendly and see if there's availability. And you have additional opportunities to talk to us. Some of the most recent community talks I've done is there was a recent develop Temporal applications with confidence. That was part of the Spooky Stories initiative, community initiative that we have in Temporal. Is a link to the YouTube. And before that, we also did a community session, an in-depth Temporal worker with a Q&A, and they went over pretty well. So if you're interested, you can go check those out on YouTube. Upcoming community talks that I'm aware of, I'm sure there's going to be lots more, and I'm sure Irina and team are going to share many more coming in the future. Is one coming up on metrics in production. Currently, there is no ETA, but the focus is going to be on worker performance and scaling, that being SDK workers, where this talk is more targeted towards Temporal cluster and information about that. Always checking our community Slack, and also join our Temporal community forum, and we have announcements channels there where you can get some more info on a lot of upcoming stuff. So the first thing that I wanted to talk about, just wanted to add, this is not going to be a Temporal 101 intro type of talk. We're going to go through a lot of stuff. Some of the things are going to be assumed that you already know about Temporal and cluster setup. Is going to focus on two things. Number one is setting up Temporal cluster, some of the recommendations that we usually give. There's a lot of questions in the community about a lot of different things, I think, that we'll cover today in slides. So hopefully everybody that's listening in is going to get something out of it. But as mentioned, please ask all the questions. And if your questions do not get answered, please, again, go to our community Slack and forum and ask them there, and we'll make sure that we address them there. So the first thing that I want to talk about is pod resources. So in this case, these are recommendations. Temporal cluster is composed on 4 different service types, which is front-end, history, matching, and workers. There's a lot of questions for users that want to set up an on-prem Temporal cluster, on what kind of resources should we give them. And these are, again, just recommendations, but they're based on some experiences and us working with a lot of users that have self-deployed this in the past. So the front-end service, these are the 1.5 to 2 CPU cores. Front-end service can be both CPU and memory intensive, and typical recommendation is about 4 GB of memory. History service is probably the one service where you have to look out the most, with 4 cores and 6+ gig of memory. There is a quote here that will be important later, is the memory utilization of history service is going to depend a lot on the workloads you're running on your temporal cluster, and we will show some metrics later on how to, and also some dynamic configs on how to help and limit that so you don't go over your allocated memory. Similar for matching service and the worker service as well. There's some recommendations here if you want to take them from the slides. The worker service, again, if you're a heavy user of schedules, this might be a little bit different for you, but this is kind of like the common recommendations that we give. So the second thing I want to talk about is the cluster throughput. So once we have determined kind of the resources, we're targeting the highest throughput that we can. In our talk here, we're going to think of cluster throughput at state transitions per second. You can think of a state transition is any sort of action that in the end results in two things: either creating a workflow execution or updating an workflow execution. So the way we're going to define throughout the slides our cluster throughput that we're trying to achieve is going to be a number of state transitions per second. And as you can already tell, this is also highly going to depend on your persistent store and other things like that. So as far as what creates state transitions, I think for create workflow execution is pretty self-explanatory, but updates, for example, workflow completion is an update, regular activity execution is an update, things like that. So there's a lot of different things that your workflows are doing, your business logic is demanding from the service, that is going to be translated into one or more state transitions in the end database writes, as such that the throughput of our cluster is going to be determined by how much we can push through that and how many in the end state transitions we can have per second. So how do you measure this? Of course, we can't just say what some number is. Number one, when you start running your temporal clusters, you have to run load tests in order to see what your throughput is. And there is also server metric called state transitions count _count. That is going to be pretty much exactly equivalent as persistence request metric for operation create workflow execution or update workflow execution. And this is the exact statement that we say here. The state transitions in the previous slide basically result in any persistence API calls to create or update workflow executions. So you can use these two queries probably interchangeably in order to measure your state transitions per second on your cluster. So the way we're going to look at this is try to target two different cluster profiles that fit most of the types of use cases that you might be running on-prem. You can achieve higher throughput, but this is the two that we're going to look. We're going to kind of go with small and large. And from these two, you can kind of figure out, what medium would be or what extra large would be, depending on your use case and the throughput that you have to set up locally. So each temporal service types can be scaled independently. And the first thing we're going to look at is the replicas. So we're going to define a small and large profile clusters and already give you a number of replicas already scaled up to whatever the profile we're targeting. So for the small cluster profile, we're targeting about 3,000 state transitions per second, where for the large cluster profile, it's the double of that, it's 6K. And you can see here how many replicas of each service type we would have as a recommendation. Now we will go through other slides and see how that relates to other things and especially with the history service. One thing to note here is that uh, here by what we're deploying is the server image. It's not the auto setup image. Auto setup image is running all four service types in the same process, so it's a bit harder to scale on this kind of level. So here we're assuming you're deploying your server image on your cluster. The second thing that comes that's also very important is the history shard count. A shard or a history shard represents a unit of parallelism or concurrence updates in your temporal cluster. And it's very important to set to some number. You have to set it. And once you set it, it's currently still a bit difficult to change this number, meaning once you set it, you have to either stand up a new cluster. There is also ways to do to migration to a larger cluster at some point as your use cases are growing. But the shard count itself plays an important role in our desired throughput or state transitions per second we're targeting with our profiles. The recommendation that we have for both cluster profiles is 2048, and that's kind of what we're going. I think you can also go with and go from there. If you currently, a lot of users are running on much lower shard count, this is fine. As mentioned, you can, with replication, move to a larger cluster that has a multiple of a shard count of what you currently have as well. But we're not going to cover that in the talk today. So once we define our shard count, we want to kind of assume, measure, is this number of shards or parallelism enough? And for this, we're looking at shard lock latency. So persistence updates operations on shards are serialized under a shard lock. And if shard lock latency is pretty high, it means DB is probably overloaded or not. It depends, meaning we probably don't have enough shards. We can't probably achieve our throughput that we're looking for. So there is a server metrics shard lock latency. If you're using older server versions, it's actually called shard lock latency. For newer versions, it's called semaphore latency metric. And here you can see the Grafana query for measuring shard lock latency. What you're looking for is typically milliseconds. From what I've seen, at least, we're looking up to probably 30, 40 milliseconds. P99 is probably something where you want to be. Lower is, of course, better. Once you start reaching about probably 60, 70, 80 milliseconds or more, in some use cases might be completely fine. In maybe high throughput use cases, might not be. Now, what about unexpected shard lock latency and shard movement? While you're looking at your shard lock latency graphs, you could see spikes that might not be expected. Usually, if you see those spikes, if you haven't scaled your cluster, you haven't been doing anything, typically means there's some sort of latency issues or issues with the persistence layer. So check that. Usually, if you see unexpected shard lock latency, start looking at your persistence stores. But they can also happen. They will happen naturally during cluster scaling or restarts. If you're doing upgrades, you will have restarts of your service type, service pods, and you will see some shard movement. And the way you can actually see shard movement that can increase shard lock latency is through these three queries, which is shard item created, removed, and closed counts. And you can expect that, especially during restarts and things like that. Another thing that's pretty important once you start setting up your temporal cluster is monitoring your history host's memory use. And if you remember, especially for history hosts, we recommended some memory, but it will really depend on the workload. And memory use will highly depend on the number of history shards and per shard cache limits. Each shard has its own cache. It's cleaned up when the limit is reached. And there is a couple of dynamic configs. We used to have only dynamic per shard dynamic config called cache initial size, max size, and event initial size and max size, which really were the number of items in the cache. And it was a bit harder sometimes to estimate the memory use given the types of workloads that you're running on your cluster. With the newer versions now, we have a history cache size based limit. When we set it to true, we can also set cache size based on bytes, size by bytes. So we have history cache max size bytes and host level cache max size bytes that we can set on the whole host level rather than the shard level itself. So hopefully these dynamic configs can help kind of monitor and also limit the memory used by your history service on your cluster. So the second thing I wanted to talk about is persistence setup and monitoring. So what are some of the persistence layer recommendations? Temporal has two persistence layers, primary and visibility persistence. Primary persistence we support, Temporal supports three layers, Cassandra, MySQL, and Postgres. Cassandra currently still, I believe, is the large-scale option, and this is the one I think in the slides that we're going to focus on as far as giving recommendations to. I am personally not expert in databases myself, but I believe you can translate this your teams to some sort of equivalent sizing and recommendations for the particular persistence layer that you're going to use on your cluster. So for Cassandra primary persistence, these are recommendations based on AWS EC2 instances. For small cluster profile, we're looking for 4 plus 4XL data nodes, and for large, we're looking at probably 9, 7 plus, or 9 4XL data nodes for this. And this is a link that you can go to see the specifications for what exactly we're looking at this point. So what to do for persistence as far as observability goes? One thing that's important is monitor your persistence latencies. And here, some of the Grafana queries for server metrics. It's important to monitor persistence latencies by operation. And the most important ones that we can focus on is create workflow and update workflow execution, and also update shard operations for persistence. But of course, you want to monitor all kinds of issues. And here we use history and quanta. So we're basically looking at P95. You can look at P99 and things like that. So basically, while you're monitoring this, look at unexpected spikes and things like that, and just a baseline that you can establish once you're running your load tests. Another thing to look for, especially persistence layer system overloaded on resource exhausted issues. So the service does emit a service errors resource exhausted metric that you can filter by resource exhausted cause. And what we're looking for here is a resource exhausted cause of system overload that can be a sign of persistence overload. And in following slides, we'll also see how to actually set some limits on your temporal cluster on especially like queries per second and things like that. Okay, and other queries or other server metrics that you have persistence request by operation. This is very important to monitor on your graphs for your persistence layer, and you can filter persistence requests by service name for specific service type. If you want to focus on the persistence request, for example, for matching service or history service, you can filter it by that. You have persistence errors with type, also filtered by operation. And this is just a query that I've put is like persistence percent availability. You can look at that at persistence errors over persistence requests and kind of get an idea if you want to present a graph of kind of like your overall availability of your persistence layer on your cluster. As far as visibility goes, Temporal does support visibility on Elasticsearch or OpenSearch and also SQL. A lot of, I think I've seen users, especially asking questions in community Slack, are running visibility on Postgres. For these type of recommendations, and again, are just for OpenSearch as far as index shard counts, master nodes, and instance counts, and you can translate that. As far as Postgres goes, just make sure that we have enough capacity on your database as your use case is growing, of course, depending on like things like namespace retention and things like that. A lot of issues that we've seen, like with at least were reported on Postgres, can be just using too small of a database, and then database size is going to matter a lot. Also with visibility, especially in Postgres. So monitoring visibility is also important on your graphs. One thing is visibility latencies. So one thing that we're trying to find out is the latency of your visibility store is task latency bucket for operation, anything that starts with visibility task. And similar query to earlier, we have like a visibility percent availability. We are looking at service errors for the most important, I guess, the visibility APIs over service requests. And you can, create a graph like this yourself if you're using Grafana, or maybe translate into your Datadog query and have that on your dashboards. So other couple of important metrics for monitoring your visibility is task latency bucket. And also, I guess, oh, is this a double slide? I hope not. It could be. Yeah, I'm sorry about that. So another thing I wanted to talk about is visibility itself. So visibility is what we call eventually consistent. So once update is made to an execution on your primary database, especially on the shard level, a visibility task is created, and then is through visibility task processors is moved to your visibility store that you configure, and that has a delay. So you can start measuring two things: visibility task end-to-end latency, which includes time of the visibility task in the visibility queue in the shard, and there is task latency queue bucket for that. And then there is another metric that you can use, which is called task latency bucket for operation visibility task. All the operations start with visibility task, which does not include the latency of being in the queue. So this is just basically latency of task processing at this point for your visibility store. So I probably would have these two graphs at least on my dashboards for visibility store. The third thing that I wanted to talk about is how to protect your cluster. Now that we have set up our cluster, we have persistent store and our visibility store set up. We got to put in some protections in place. So every single temporal service type, that being front-end, matching, history, worker, can access persistence. And overall is important because we might have different workloads running against our temporal cluster. We might have some rogue clients. We might have some unexpected code, bugs, whatever, that can create a very large, possibly unexpected workloads, or expected, depends, putting a lot of pressure on our cluster. So it's important to set query per second limits in our temporal dynamic config. These are recommendations for both of the two cluster profiles that we have defined earlier. So one of the things we want to set is front-end persistence max QPS, which is basically we're setting the queries per second that per host on our front-end service level. So if we have 4 front-end hosts, each one would have the 2,400 queries per second limit. Same thing for history and matching. And then we can set over, it's important also, depending, because we might scale up or down, things like that. It's important to also set especially on the history host, the persistent global max QPS to limit the overall persistence per service type in dynamic config. It's also interesting and probably important to also set a per shard dynamic config for max QPS, especially, well, of course, on the history service. And this is the reason, because some use cases we might talk to them later can create a lot of pressure on a single shard. And this is not something you you can control. It's really how the workflow implementation or the use case is implemented. So how your developers develop the use case sometimes can put a lot of pressure in a single shard, and that's why it's kind of important also to put QPS limit on the single shard as well on the history service. Another thing that we need to do is protect our front-end service. So all clients and your SDK workers, all the communications between basically outside of the cluster and the cluster happens through the front-end service, through gRPC. And it's important to set two things, your request per second limits and also your concurrent limit of especially polars. The first one is important because we basically don't want to overwhelm our service with requests. The second one is the limit that basically limits the number of long pole connections that all your clients basically and workers can make against our front-end services. And these are the same recommendations numbers independent of the cluster profile that we have listed before. For the RPS limits, we want to set it per namespace across all front ends. So this would be front-end global namespace RPS. And then we also want to set RPS limit across all front ends independent of our namespaces, which is front-end global RPS dynamic config. Another thing for concurrent polar limits, we want to set a per namespace limit across all our front-end hosts, and that's done through dynamic config front-end global namespace count currently. And we can set that to 20K in this case as a recommendation, something you can do yourself. Now, other things that we want to do, once we have set these limits, we want to monitor cluster access as well. So one of the things, Temporal gives you metrics out of the box is service requests and service errors. So you can build a graph that shows both of them, for example, just this is an example graph, but you can do some rate, basically service requests where service name is front end and put service errors on the same graph and you can kind of monitor that pretty nicely. But you have access through server metrics to both. Other things that you can do is you can look at requests by namespace. So for example, service requests can be filtered by namespace. So you have multiple namespace on your cluster that your clients are creating. Then you can see a per namespace RPS that they're generating. Same thing with request errors, and you can also filter them by error type. So for example, service errors with type is a server metric that you can filter by error type, and you can see all kinds of front end, for example, service requests errors. They're happening over a period of time. Okay. What else do we have? Other things that we can do is we can build graphs for key API latencies. For example, this graph also uses service latency bucket. It's a P99 for operations like start workflow, signal workflow execution, which are probably how your clients are starting your workflow executions, but also important ones like respond workflow task completed and respond activity task completed, which are important metrics, to the client workers are sending to your service front-end service. Of course, just like with anything else, as we're monitoring our systems, we need to understand resource exhausted errors. So we have, again, the service errors resource exhausted metric. Look for resource exhausted cause that is RPS limit or concurrent limit. RPS limit is going to give us, depending on our limits that we set on in our dynamic config, as we previously mentioned, we would look at and this can be filtered by namespace as well. So you can see which namespace is actually hitting their RPS limits, which namespace is hitting their concurrent polar limits. And then, of course, for system overloaded, as well, we can see maybe there's particular namespace that's tripping and causing some sort of possible persistence issues or overloading our persistence as well. And then we go back and see if we can increase or decrease the limits again, and see what to do. There is for concurrent polars, we also have the service pending requests metric, where you can see the concurrent polars per namespace as well, and then that would translate into if that's too high, that would translate into the resource exhausted errors for resource exhausted cause concurrent limit as well, and you have some indication of which namespace is hitting which sort of resource exhausted issue. So probably, I know we're going through this very fast, but we also have, the last chapter, which is monitor client bottlenecks. And in this case, a lot of times the use case implementation or what your clients are doing can highly influence how your service needs to be set up. And a lot of times, a lot of issues that do happen where you're detecting in the service level are actually caused by either the workflow implementation or the use case implementation or things like that, or even the worker setup. So with temporal in general, like underutilized workers can have a lot of or not underutilized, under-provisioned SDK workers can have a big effect on the cluster as well. So in this case, we're going to look at some of these types of bottlenecks on the client side that we can detect and then go back to our development teams and see if we can improve the situation overall. So as mentioned, certain use cases in their implementation can put extra pressure on your temporal service. So we are looking to detecting that. And yeah, so this is basically saying what I said earlier. And one of the things we want to look at the first is schedule to start latencies. Schedule to start latencies of things like workflow and activity tasks is basically the latency from when on our service side, we created a workflow or activity task and we've placed it on the matching task queue until the service itself is able to dispatch this task to one of the polars on the worker side, on the SDK worker side. The larger these latencies are, it could be an indication of a possible under-optimized worker deployment, SDK worker deployment, that's not fully up to able to pick up those workflow tasks right away or activity tasks. So there is the metric for that is this task schedule to start latency. You can give it a specific namespace or filter it by namespace, and you filter it also by task type and operation. And the operation and the task type will either be workflow task or activity tasks. So even from the service level, we can actually see if there is particular namespace that has very high schedule to start latencies. Oftentimes, this high schedule to start latencies for activity tasks is something completely expected. Most of the time, can be related if it's normal to like clients needing to rate limit certain activities that access downstream services that could be rate limited, either on the worker level or on the task queue level itself. So it's not necessarily an indication that something is wrong, but if it's unexpected, then that's something that could be improved. And the reason why we want to look at schedule to start latencies is that the second part of this slide, which is workflow tasks that cannot be dispatched from matching task queues to your workers, within what we call sync match, or within, let's say, some number of milliseconds, um, is the matching service actually has to persist it. So if we see high schedule to start latencies, especially for activity tasks, which can happen a lot, we got to start looking at persistence request metric for operation create task. This operation is called when matching has to actually persist the task from the task queue to your persistence store. And we should, that's going to put more pressure on our database, basically. So in this case, we see like two metrics that we can kind of have an indication that we can go to our dev teams to and say, hey, it looks like we have to probably scale up our workers and do some worker tuning or whatever in order to reduce the number of tasks we write to the database. And maybe they'd come back to you and say, yeah, it's expected. We're rate limiting activities, things like that. But it's something to look into, nevertheless. To see what time it is. Okay, we still got time. Okay, so the second thing where we want to monitor client, quote unquote, bottlenecks is this, what we call the per workflow lock. So updates to a single workflow execution, updates like recording signals, any sort of update that we talked about, is going to be serialized under what we call the per workflow lock. Some use cases that we create can cause increased latencies due to large number of transfer, what we call transfer tasks or updates for a single execution. And a lot of these generated tasks or updates to a single execution, they all have to wait on this per workflow lock. And this can start blocking your history host or shard transfer queues and increase latencies as well. And to measure this workflow lock latency, we have this cache latency server metric for operation history cache get on create. And this actually can be very useful, like even like sometimes like once you see increased latencies from a number of different service operations, even start workflow execution or signal with start workflow execution, it's always good to check your workflow lock latency to see if this is actually caused this increased latency by the use case itself, trying to really have very large number of concurrent updates to the single workflow execution. Another way to check this is through resource exhausted, again, service areas resource exhausted metric. This we've seen a couple of times already, where the resource exhausted cause is called busy workflow. That's another way to detect this. And the typical workaround, if you see workflow lock latencies, is to schedule less activities async. And that's even a lot of, that's got to be on high scale a lot of times, depending on the cluster, but also it's typically activities that all are started async and complete within very short or the same time, basically. Um, it happens a lot. And then another thing that can cause this typically that we have seen is having too many, you start a bunch of async activities, for example, and they all heartbeat at a high rate. So they're basically a large number of async activities, they all send heartbeats, and it's all for the same workflow execution. So again, this is a per workflow lock. So Temporal does scale out on number of workflow executions. However, this is one of the limits for a single workflow execution that we have to be aware about and to measure the latencies if we run into this, and then work with our dev teams to actually start looking into possibly rewriting the implementation for the use case a bit in order to achieve higher throughput of this particular use case. Okay. Another thing that we have is we can actually, from the server side, monitor activity and workflow task timeouts that are happening on the worker level. This is for regular activities, of course, because the service manages timers for regular activities. If your clients are running local activities, this is not going to work. But this is just when we talk about activity here, we're talking about regular activities. So client SDK workers can, sometimes run into high CPU, they can run into compute resource limits, and things can start slowing down. This can cause activity and workflow task timeouts. This actually can also start triggering retries of activities and workflow tasks that are unexpected and probably not needed, and put more pressure on our system, on our basically cluster. So from the server side, we can actually monitor activity start to close timeouts. Start to close timeout is basically means the amount of time from when activity task is dispatched to one of the activity workers until the time the user specifies in their activity option start to close timeout, which is the max time of a single activity execution. We can actually monitor with start to close timeout. Oh, uh, this shouldn't be there. Okay, sorry. Another thing is activity scheduled to close timeout, which is the also another activity timeout from when activity task is scheduled until it's started. It's a non-retrievable timeout, but monitoring this can be a pretty good indication of, for example, user workers being down. Because if the user doesn't have a specific use case of rerouting activities to different workers and different task queues, this can be pretty good indication, hey, maybe they have their workers down, things like that. And also we can monitor there is also scheduled to close timeout, but I think I copied the start to close timeout twice. But there's ways to monitor basically all the activity timeouts within your cluster. So that's all I had for today. I know it was a lot of stuff. We went through it pretty fast. And if there is any questions, we'll go through that. Thank you very much.
Thank you, Tiha. We actually have a lot of questions in the Q&A sections on Zoom. Feel free to pick some of them and answer live, and we will follow up with all non-answered questions in the Temporal community Slack.
Okay. Yeah, sure. Thank you. Okay, so I'll just go through some easy ones. Will the slides be shared? I'm sure they will be. What is the default for num history shard? That depends. If you use like I believe the Helm charts, it's very low. If you by default, I believe is like 512, but you got to look at the server repo, go to Docker folder and look at the default template. But if you use the default template for generating the static config, if not, if you maintain it yourself, then you define the default yourself. But yeah, so I've seen a lot of users run like 512 default. I think in some Docker Compose repo that we have, it might be even before. It's fairly low, but make sure that you check what it is. Your generated static config is going to be on your any of the service type pods under etc temporal config docker YAML. That's what the file is called. So you can look at, bash into one of your service pods and see what its persistence dot none history shards is the static config. Okay, I've read on Slack that having horizontal auto scaling of the temporal service is not recommended. Is this still true? I think scaling is fine. Usually you want to scale individual service types as needed. The reasoning for that is, especially in the history service, every time, well, and also matching, every time you do restarts or resizing, we have shard and task queue also rebalancing. And we have shown some on one of the slides, some of the shard creation, shard removal, those metrics that can then up some latencies and also shard lock latencies. So every time you scale up or down, there is going to be a bit of a delay in performance. But so usually, you want to keep it stable, but I guess sometimes you can scale if needed. So let's see what else we can do. Jed is asking, are there specific reasons Cassandra is in your persistence recommendation, or is it just because that's what you all have mostly used? Both, I think. I think Cassandra itself is most scalable, and that's at least what I think I've heard over time the most. But that doesn't mean that you cannot use other database layers as well. And I think a lot of users, is use them as well. Um, let's see. Are these discussed queries already part of the temporal graph? No, they're not. One of the things I wanted to do for this talk is start adding those queries to. We do have a GitHub temporal dashboards repository where we do have some server dashboards, and one of the things I wanted to do is add that. So we'll be doing a PR soon. Okay, one question from Anonymous is we have a set max QPS 9000 default, and we have four custom search attributes. When we do list workflows with 1000 count, we get a context deadline exceeded. In front end, we get max QPX exceeded. So front end service, I think, directly queries your visibility. And I believe one of the things I didn't show in the slides, there is also, I believe, APS and especially RPS limits for visibility, specifically in dynamic config. And I don't know, I have to check if it's for QPS specific for visibility too. But that could be it, that you're not hitting your primary persistence limits, but your visibility dynamic config limits for that. Do we have time for more questions or no?
Yes, I think we can cover three more questions. And
Okay.
like I said, we will follow up with all other questions on the community Slack.
Okay, first of all, Ahmed says this is really awesome and very insightful. Thank you very much for that. I appreciate it. What's the best? Anonymous also asks, what's the best way to monitor DB CPU peaks? Uh, I think, like depends on your database type, and I'm sure somebody here that's a DB admin much better than me will be able to give you more. But ask this question in community forum or Slack, and I'm sure so people can give you recommendations of what they're doing. Um, These asks, is there a predefined set of alerting rules for Alert Manager? No, we don't have that out of the box yet. I think that's something that we also would like to add at some point in time. But it's definitely going to be a community effort. I think we're looking for always contributions and ideas. And if somebody has alerts for that and would like to share, again, Slack and community forum, that would be awesome. Okay, so Yuri asked, Temporal Server and Temporal SDK by default produce quite a lot of metrics, but specifically those metrics have quite high cardinality. Um, For the cases of Temporal Server, we run a dedicated Prometheus server, which has its own ingestion rules to prevent overloading Prometheus resources. What can be the option for Temporal Client SDK? Any chance there can be sort of configuration to filter metrics on the client SDK in the future? Okay, that's a great question. I think it's a question that comes up quite a bit in the community, and especially for worker metrics where there's a lot of metrics that are being produced, and which is an amazing thing. I think like the more metrics observability we have, it's the better. However, just the sheer volume of metrics that is being generated oftentimes creates a bit of a cost for users. Not a bit, sometimes a lot. The best way I've found out how to do this is actually, well, I run Prometheus, and there is rules to actually uh, get rid of some of the metrics. And I have an example. I can, if you ping me on Slack after this, or today or tomorrow, or whenever you have time, I can show you those rewrite rules where you can actually emit. On the server side, another thing I found is the same rules to not emit metrics on the Prometheus level. It's a Prometheus config, and I'm sure others have it as well, is to sometimes omit certain namespaces that you're not interested for. And that can also reduce the volume of metrics you're pushing down and in the end paying for wherever your end target is for them. I hope that answers your question. Okay, let's see. What else? Do we have time for more, or No, I'm trying to look.
Yes, two more.
Okay. Uh, okay. Is there any data you can share on the largest Postgres back deployment you've seen and how much state transitions per second they support? I I can look back and share, but yeah, we have worked with some very large use cases on Postgres in the community, and they ended up eventually moving to cloud, I think, for the particular one that I'm thinking of. But I think it was similarly to the large use case of about 6,000 state transitions per second. But I can go back and check and share it. Okay. So one more, Raymond G asks, I'm noticing that the temporal cluster also emits some SDK metrics like activity schedule to start latency. Should we use this alongside SDK metrics emitted by the temporal workers? What's the difference between the two? Okay, yeah, that's a great question. And yeah, a lot of times like this creates a confusion and it comes from the temporal worker service, which the name itself also creates a bit of confusion itself. Um, so one of the four services we've shown the four services we have front end history matching and worker service. The worker service in the temporal cluster has a very special role that it runs actually temporal internal workflows. So for many things like some sort of scavengers, things like that, also very highly involved with schedules feature, and and so it acts actually as an SDK client because it itself connects to the service either through front end or what we call internal front end service, which we didn't mention in the slides, but I would look at the docs and for that too. So all the the workers that run in the temporal worker service for all of these workflows are basically producing SDK metrics, and that's why you see them there. So they're basically have nothing to do with the SDK metrics that your actual SDK workers, whatever programming language SDK you use in Temporal. So yeah, so you can yeah, they're there, but they're more for the internal workflows, the system level workflows running on your temporal worker service, not your SDK workers. I hope that helps.
Tika, we can spend some time for other questions since we have a lot of people here. So feel free to pick any other questions as well.
Okay, I will. Um, okay, so Igor, as we're planning to, hi Igor, by the way, I know Igor from the community. I think you still have some outstanding questions in Slack. We're planning on using schedules extensively, hundreds of thousands of them running. You mentioned worker would need to be scaled differently. How exactly? I think, as a lot of these things, I am kind of like there is also some dynamic configs that I've seen, and also as far as scaling of worker service would also depend on the number of schedules, things like RPS limits on the schedules. I am not basically then can't give you an answer. I would ask in community, and I'm sure guys like also David Rice can help with that and much better than I can here on call live. But yes, there is ways, certain things to consider as far as how many worker services you need, how many workers you want to start across all your schedules, RPS limits, a lot of things like that on schedule starts that I've seen users needing to look at and address in order to get this type of scale for on-prem. But yeah, please ask that in community and we will get to you on that and make sure that you can do that. Another one, according resources do you recommend to set limits for temporal workloads? Okay, so yes, I mean the limits, some of the limits we talked about are limits like requests per second that are going to eventually start rate limiting your client APIs trying to do different things, like, or even your workers, pull workflow executions, start workflow executions, signal workflow executions, whatever. So yeah, setting the limit on the temporal workload itself. I mean, if you can't scale up your cluster, or if you have a cluster that currently, already existing that can support only up to certain type of, level of workload, then yes, maybe, but there is other ways to deal with it. Typically, you will be able to grow along with the workloads and be able to scale up, even if it means like moving to a larger size cluster via, multi-cluster replication and things like that. But yeah, I don't know. I really don't know how else to answer that question. Um, see what else. Um, Another question from anonymous attendee. We have what could be considered an XXL cluster, which could reach 40,000 state transitions per second. Any specific recommendations? Um, I mean, yeah, for on-prem, like you can probably like start looking at what we had for large and then upsize that. Again, load testing, look at shard lock latency, persistence latencies. You probably need a lot more, beefier database or persistence level, number of nodes and things like that. On the Cassandra side, yeah, it's going to be interesting. Of course, I'm not a salesperson here, but possibly looking at cloud as well could be an option. Being temporal cloud, of course, if the cost for maintaining such large cluster is maybe equivalent or if not more, but of course that's up to you. I don't know. I think we've got a lot of these questions done. If there is any new ones, let's see. Okay, there is one. What metrics can we look at in temporal cloud to determine the rough size of a self-hosted cluster so we can get an idea of a cost comparison between the two? I would reach out on Slack with that question. We have like people in sales and solution architect teams that work with a lot of users, specifically this question, which is cost estimation. I am not involved with this. I'm more involved in the technical side, but we have people in Temporal that will be able to help you with cost estimation like that. And just ping on Slack. We have a community channel, or we have also support cloud channel on Slack, and somebody will get with you and give you that, help you start comparing the cost. That's a good question too. Thank you. Andrea, let's answer this one. You recommended several changes to the dynamic configs for RPS QPS limit. Does it mean the default values are too small or not adequate for production? It's just the values we recommend depending on the two cluster profiles. Um, a number of users that I've worked with in the community have been running in production on their cluster without ever changing anything in dynamic config, and they're running fine. But then again, you always should be looking at those RPS and QPS limits. The defaults are there because, either they have been there for a long time, or they're based on some, overall just kind of baseline recommendations. But I think, you should seriously look into to what you want to set them. If they're too high, which I think a lot of times they are, some of the dynamic configs I think that we have recommended in these slides actually lower the default values by a little bit. And also it's important to understand that you want to use those dynamic configs that sometimes limit RPS across all the uh, service types, rather they're per host. Because as you scale those service hosts, let's say you only set RPS limits for a single per front end host, but then you scale out, then you allow a lot more requests per second across all. So setting both limits, like global and per service type, is important if you want to kind of not run into problems. But yeah, I hope that answers that question.
Okay, I think we can pause here. Thank you everyone for attending our session. Thank you, Tihomir, for your insights and answers. Thank you so much again, and I wish you happy holidays and a great rest of your week. Thank you.